Once we've shipped our software, we want it to keep working. That's a given. But there are two main schools of thought on how you guarantee the software is going to work once it's in production. The first is get it right before you ship it. That's professionalism. You add tests, you add types, you add a QA department, and you make sure it's rock solid before you press deploy. The other approach, very different, is the Erlang philosophy. You just say, it's going to crash sometimes, so let it crash. And then put your engineering effort into dealing with crashes so gracefully that nobody notices. Now, there are a number of projects springing up these days looking at that choice and saying, why not a bit of both? So this week, we're going to turn our attention to Riot, which is the brainchild of Leandro Ostera, and it's his attempt to bring the runtime system of Erlang to the compile time system of OCaml. How do you do that? How do you take the best ideas from Erlang's Beam and make it work with one of functional programming's favorite compilers? How do you make it perform? And what is it about OCaml 5 that makes that approach more feasible than ever? I can promise you that Leandro is going to make it enormous fun to find out. So let's get going. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Leandro Ostera. My guest today is Leandro Ostera. Leandro, how are you?
Hi, Chris. Happy to be here. Thanks for having me.
Glad to have you. I gather you're house sitting in Stockholm this week.
Correct. I am cat sitting for a friend, actually. So Leia the cat, a little white cat with like dichromia, two different colors.
Two different colored eyes. Yeah, like David Bowie's syndrome.
Exactly. Kind of like a Bowie cat. I might swing by here and there. Hope that's okay.
Awesome. Yeah, we love guest visits by cats.
Nice.
So I've got you. God, you're doing a lot of interesting stuff in the world of OCaml and Erlang and the Beam.
Thanks. Yeah, I mean, there's quite a few projects that have been happening on that space. I've been working in both ecosystems for nearly a decade on different areas, but open source stuff more recently, right?
Yep.
The latest one is Riot, which I think this is one of the things we'll be touching on today.
Absolutely. That's a long time to be in that space. You must be an early adopter of OCaml, definitely Erlang, right?
Oh, I don't know if it's in that order, because I feel like Erlang has been much more stable for building systems, right? Like for longer. Not to say that OCaml isn't, but for example, I remember back in 2014, 2013, right? I was thinking, I was sort of stuck in that rut of the web developer, realizing for the first time, everything I do is move JSON in and out of a database, right, into a form on a web. Yeah. It's like, oh, do I really want to do that? Like, there has to be more to this. My problems maybe are not big enough, right?
Yeah.
And I taught myself Erlang because I thought that not having like proper academic qualifications as a software engineer or a computer scientist, right, it would be harder to get access to bigger problems unless I taught myself the tools that are normally used to solve bigger problems, right? So I went through the Learn Use from Erlang book. And it was pretty obvious to me that this was definitely a tool that was for larger problems than I had dealt with before. Compared to Ruby. Yeah. And I think even then there were already quite a few Erlang jobs for people to pick up. It's still a niche. Like, we're not talking Go here. We're not talking like Java, right? But it was already pretty well established in the sense that it had practices, right, around how to start a project, how to grow it, how to ship it, how to maintain it. Like, Erlang coming from the telecom industry, where they had very strict requirements from the industry to be able to ship something far away into like, a switch and be able to reprogram it remotely, right? They needed all of this sort of, let's say, dogma around how to build something, right?
Established practices, let's
say established practices. Yeah, BCPs, best current practices. Yeah, exactly. That. So I feel like Erlang has been more established from that angle than OCaml has.
That's interesting. We kind of associate Erlang with the whole scalability, fault tolerance thing, but the idea that it's established a lot of productionization stuff.
Yeah.
I'd not thought of that. Yeah.
I'm not gonna lie, it's not the pretty kind of product like productionization. Did I say that word right? Yeah.
Yeah, you said it right, but I think I might have made it up.
No worries.
It's not a real world.
It's not a very pretty like story, to be honest. It's kind of like a engineer kind of story. Like you have the tools, you have to figure out to assemble them together. But just having OTP, right, which used to stand for Open Telecom Platform, which is like the big framework of philosophies and actual code, right, for designing Erlang systems. It's something that most programming languages don't have, right? Most languages evolve that. But Erlang was like, hey, you want to use the language? Here's a big book of how to build systems in Erlang.
Yeah. So we're going to get into exactly that, the fact that most languages don't have Erlang and what you've been doing about that. But in order to get there, I think we need to start with OCaml. What tempted you away from Erlang into OCaml?
Ooh, that's a good question. So I think one of the reasons that I jumped ship, or let's say I had 1 foot on each ship, was that Erlang, even though it's super scalable in terms of runtime performance or how many concurrent users you want to have, right? I think it has a problem. And it's a problem that every dynamic language has. And that is, the more code you have, the more complexity you have, right? The more cognitive load your developers need to be able to juggle, right? So as your system grows in terms of complexity, like features you have there and the interactions between them, but also the amount of code you have to deal with, right? Like different dimensions of scalability, right? You need more and more tests, for example, to ensure that some basic things are not going to blow up in your face. It does have a lot of tools, and I guess we'll talk about them at some point, to prevent those failures from taking the entire system down, right? But that still doesn't mean that a single person can onboard into a code base large, let's say 500,000 to 1 million lines of Erlang, and comfortably make a small change, confidently make that change, knowing that, everything's going to be okay, right? You might have to run batteries of tests. A test, they don't show the absence of bugs, they just show the presence of bugs, right?
Yeah.
So from that point of view, at some point, when I was working at Klarna as an Erlang programmer, right, a colleague of mine, Daniel McCain, excellent engineer, by the way, he kept pestering me to learn Haskell. He's like, you should be learning Haskell. It's like, why? What is so good about Haskell, right? And we even had a couple of sessions where we chatted about Haskell and we wrote a little basic interpreter in Haskell. Yeah. And I was like, I guess I can see how this works, but it didn't quite click for me. And through that conversation, I started looking into other programming languages that were typed, right? And obviously, you have Haskell, you have the Scalas of the world, right? And I found Idris, which was maybe...
Idris?
Yeah.
Wow, not many people go on that journey. Yeah, okay.
Yeah, especially not straight from dynamic to something like that, right?
Yeah.
I had experience with typed languages such as C before, but nothing like Haskell or Idris. So I wrote a little bit of Idris and I thought this is really cool, right? Like the ability to have data that carries proofs, right? Like the auto-proof feature that they had was mind-blowing. To this day, I don't think I fully comprehended, right? But
it's kind of a research language, so you're allowed not to understand the whole thing because the author doesn't, right?
Exactly. They're still researching a lot of things, right? And I think the main idea I got from that was that instead of building reliability in your systems the Erlang way, which is having supervisor trees that make sure that the application is reliable or resilient to failures that will happen. Yeah. The Idris approach says we're going to build an application that by construction, by design, right, can never fail or handles all of the possible errors. So when I took that idea, I was like, I love that. How can I use that? What else is out there? And so I found real world OCaml, just dialing down the type safety to something that I could understand.
Yeah. Idris might have fair claim to be the peak of type systems astronautiness.
Yeah, I think so.
Yeah, and as you come slightly back down to the mountain to breathable air, you probably do get to OCaml.
Yeah, it's like in that spectrum, OCaml is like the go of functional programming languages, and I'm like, I'm gonna stay there.
Okay. So what happened next with your OCaml journey?
So I started learning OCaml and I started doing some interviews in OCaml. And I had one interview that went very poorly because I didn't know as much OCaml as I thought I did. Oh. So Yeah, like they asked me, okay, let's just like build a transaction lock between these processes, and I had to Google how to open a file, and it was embarrassing.
Okay.
Yeah, but over the years, I've been trying to use more and more OCaml in different places. Years later, I joined a startup, and we had to build tooling internally. So we built a system in Erlang, and we had to build some tooling to be able to synchronize data, essentially a model, right, across the backend and the clients. And we had to do a lot of like, let's say, mix and matching of external data sources, right, into our own data model. And since I had been working before that at Spotify, and I have been exposed to ontologies, I thought we should build an ontology for this, right?
Okay.
And we built a code generation tool in ReasonML, which is just a new syntax, or I guess not so new anymore, but it was a new syntax for OCaml, right? That was
Yes,
more
it's
approachable.
just syntactic sugar on top of OCaml, right?
Correct,
ReasonML.
yes.
Yeah.
Essentially, it's just like, what if OCaml had semicolons, right?
The most important question in programming.
Yeah.
What if we added semicolons?
Exactly. Would semicolons fix everything? And turns out it kind of did for a lot of people, right?
Okay.
So we built these tools there, and we were able to maintain sort of the generation of Erlang code and also JavaScript code, right? All from that tiny little project. And that was really nice. And since then, I've been on and off in different companies using either ReasonML or OCaml, and more recently Rescript, right?
What's Rescript? I've not heard of that one.
Glad you asked. So OCaml eventually got this new syntax, was called Reason. But the community in Reason had sort of two purposes, right? One part of the community really wanted to be closer to the web, right? They wanted just to bring the OCaml type system to the web. And the other part wanted to use the Reason syntax to write native programs, right? And the tool chains kind of started diverging. And at some point, there was this hard split, a whole rebrand, right? Where people said, you know what? We're going to grab whatever we have right now, and we're going to start building exclusively for the web. And we're going to hyper optimize the language, the syntax, the tooling, right? So that adopting that language in a web project, right, is just chef's kiss, right?
Right.
And they did. It's just a blast of language. Like today, if you ask me, hey, Leandro, let's build a new like startup and we'll do web things, I'll be like, yeah, we're going to use Rescript for that, for sure.
Okay, cool. And that presumably just compiles to JavaScript, or?
Correct, yes. So there's this whole compiler that used to be called BuckleScript. It's called Melange these days, right?
Oh, yeah.
That it's a source-to-source translator, and it compiles to super idiomatic JavaScript. It's kind of scary. Like when people look at it and go like, whoa, how did it do that? You know, because it even includes support for like JSX syntax. So you can do like your typical React style, like components and everything. And it translates those correctly. And you go like, holy crap, this is excellent. Yeah.
Okay. That sounds like a lot of fun. That sounds like something we could dedicate a whole podcast to. Yeah,
absolutely. I will give you directions of who to talk to bring for that.
Cool. But you stayed more in the back end world, right?
A little bit. So to me, like the distinction, it's more about like what kind of domain problems you want to solve, right? And what customer problems we want to actually get into. Because there's a lot of customer problems you say, no, I don't want to solve that, right? As a company. So most of my career, I worked with startups. So I've gotten used to have to sort of move around and say like, okay, now we need you to do infra or DevOps or backend or data engineering or this and that. In fact, today, I'm like, my day job is being a product manager. So I like literally don't write any code today, right?
No.
Yeah, exactly. No, I'm actually very happy. But anyway, so I think I did a lot of backend work because it's the place where you have the most freedom to make bad decisions, right? In the front end, it's like
categorize it.
In the front end, there's a lot of like constraints from expectations, right, from the rest of the web community, right? Like you want to use React, for example, it comes with a bunch of different. Everybody still does things their way, right? But there's a bunch of ideas, right, and frameworks and sub frameworks and libraries that just put a lot of constraints and on the back end.
Users
sometimes
have a lot of
like
expectations about the right way things should be, right?
Exactly. Yes.
Yeah. In that sense, I suppose the back end has fewer stakeholders to worry about the way you're solving the problem. Yeah.
It's like as long as you give me an API and the API is doing the thing, then I don't really care how you do it underneath, for the most part, right?
Yeah. Okay, so we're going to get into the Erlangness of OCaml that you've been working on.
Yes.
There's one more step I think we need, which is you told me that this was changed significantly by the introduction of OCaml 5.
Correct.
So tell me what's interesting about OCaml 5.
Right. So prior to OCaml 5, OCaml 4 and below have been historically single-threaded, right? If you wanted to run an application, it will run on a single OS thread. Even though there is something called thread in OCaml, which is not really a thread, it's just another thing, and please don't use that. OCaml 5 introduces two things. The first one is what we call domains, which are actually OS threads. They have a little more, like, I guess they call something differently because there's some more magic to them, right? Okay. That allows the garbage collection to work well across them and so on. But basically, you can say, hey, OS, I need a thread, and then you get a second thread. And now you can actually run parallel code, right? Between those two cores. Mm-hmm. And the second thing is that it introduces effect handlers. And this used to be called algebraic effects, but apparently, I've been corrected from the presentation I gave a couple of days ago about BobConf. They're not called that anymore. Now they're called effect handlers. The algebraic part just was dropped.
Is that just pure marketing? Because the word algebraic is scary.
I don't think anything about OCaml is pure marketing, to be honest.
Fair enough.
Yeah.
Okay. Effect handlers. Tell me what an effect handler is.
All right. So an effect handler is basically a try-catch, right? Like that's the easiest way I can put it. So everybody in every language can be like, oh yeah, I grasp what they do. Is to say, you have exceptions in most languages. Most of the time you can do raise or throw or something like that. And then you raise that exception. And as long as you have like a try-catch somewhere above that, like in the hierarchy of the program, right? Then you'll be able to say, oh, I will catch that exception, right? And then I will do something. Now, the difference is that once you catch that exception, you can do something. And then you can say, let's continue the code exactly where the exception was raised. Now, when you do that, if you generalize it or like change the name from exceptions to effects, now you can perform an effect anywhere in your code. And as long as you have this try-catch, which we call handlers, then you'll be able to intercept that effect, do some work, and then eventually, if you want, resume the code exactly where it was left. So,
okay, give me an example of that isn't exceptions.
Yeah, absolutely. So, for example, I think the example I want to give you is like how we use handlers in Riot. But
we'll get there.
Let's say you have a function called random, right? Okay. And it will give you a number between 0 and 1, right? Okay. You can implement that as an actual function, or you can implement it as an effect. So if you implement it as a function, if you want to like replace what that function does, you kind of have to have something like a mock or inject the function into your work, right? So you can replace it. And so if you want to write a test where you want to see what happens when the random returns 0, right? Yeah. Then you can do that. Now, let's say we don't have a function, but we have an effect. So we call like perform random number, right? Yeah. Now, that code without a handler doesn't do anything. In fact, it fails in the same way that raising an exception without a try-catch does, right? Unhandled exception, unhandled effect.
Compile time error.
No.
Oh, okay.
No, not compile time. Like even in OCaml, exceptions are not typed. Like obviously there's a type of exceptions. You can pattern match them with types, but they're not tracked in the signature of the functions, right? Okay. Which is different from other languages, like even Java, where you say like, this has checked exceptions, right? Or Swift. I think Swift does it super nicely, where you can say this function throws, and then if you call that function inside of a function that doesn't throw, then you get a compile time error saying, hey, you need to tell it that this function also throws, and so on. Yeah. But anyways, so now we want to grab that code that has a handler, an effect, right? And we want to run it for a few different tests. In one test, we just wrap it with an effect handler, right? That when it intercepts the random effect, it returns the value 0, right? Okay, yeah. And now we continue the test, the code. So now random, that performing of that effect, gets sort of replaced by the value 0, and you continue the execution of the program. You can see how this can be used to mock things in some ways, right? Yeah. It can also be used, for example, to replace the kind of random number you have, right? Like you could go from something that's pretty naive to something that is like cryptographically safe, right?
Yeah.
without changing your program at all. So
It's
it's
something
really
that
powerful.
needs an external key to be plugged into the system to, okay.
Like I think it's a super interesting way of detaching how the effects are performed, right, from where the effects are needed.
Yeah.
And that lets you like customize your program in interesting ways.
Yeah, there's a hint of dependency injection in this.
Yeah.
Yeah. But it
100%,
plays
yes.
out differently in code.
Yeah, like it doesn't look as much as well. I will declare my dependency. It's more like you will have a function called random that under the hood just calls perform this effect, right?
Yeah.
So to you, the user of this library, the random library, you're just calling random, right? But the provider of the library gives you this effect handler that you wrap your program around. And this is why you'll see a lot of the newer concurrency libraries for OCaml coming with a top level like run function. Because that function installs the handler. It's like saying, we add that try catch around your entire program, right?
Right. So it's like building up the program and then when you're ready to run it, saying in what context it runs.
Yeah, exactly.
Yeah. Okay. I'm with you. So those two things, so threads and effect handlers, why does that lead you to think now is the time to start porting my favorite bits of Erlang to OCaml?
Right. Yeah. So the main reason is that we didn't need the multi-threaded part, right, to do this. But now that we have it, is that we can do it really well, right? We can actually, for some use cases, maybe even be competitive with the Erlang VM, which I think it's really interesting. Effect handlers allow us to say you have a function, which will be your process,
right?
And when you want that function, right, to receive a message, for example, right, we will intercept that effect and we will suspend your process, which means we will not immediately continue, right, the execution of your process, your function.
Okay.
And that allows us to say, as a function executes and a function corresponds to a process, so it could be like a recursive function, for example, right? Mm-hmm. As it executes, eventually we will know when it's time to say, all right, enough, suspended. Let's let a different function run now.
Oh, so effect handlers allow you a way to write something like an await keyword as an effect, and that cracks open the let's make a nice actor model inside OCaml. I'm with you. Yeah, yes. Yeah. Okay. That's okay. So take me through what you're doing with that. How much of Erlang are you trying to build?
That's yeah. So I can tell you what we're not trying to do. That would be a shorter list.
Okay.
So like we started the Riot maybe last September, right? Mm-hmm. And it was like, okay, let's see if we can make a process, right?
Yeah.
The core abstraction of Erlang. If it suspends, we can resume it. Great. Mm-hmm. Let's see if we can send in messages, right? And we implemented the message signal. So now two processes. We have a function called spawn. You call that with another function, which is the body of your process, right? And then you get back, when you call that function, you get an identifier from the process. So you can use that to send messages to it, right?
Yeah.
And we managed to make that pretty fast as well. Like just speeding up a process is just allocating at like 140 words, a tiny data structure, right? Mm-hmm. It's even smaller than in Erlang, if I can brag about it.
Oh, really? Because the actors are famously low overhead in Erlang.
Yes.
Oh, nice. Well done.
Thank you. I mean, it's still very early stages, and it doesn't do like a third or like a tenth of what Erlang does. But it will be interesting to see if a year from now, 2 years from now, it's still that small and that fast. But this is where we are now, right?
Yeah,
being real. So we got messages between processes, and we wanted type messages. So we made some design decisions there, right? Yeah. Messages are also just data, and because data by default is immutable in OCaml, then sharing that data is pretty cheap. Yeah. There are edge cases like what happens if I make a message where I have a mutable value inside of the message. You can do that. Don't do it, but you can do it, right? Like otherwise you'll send a message and then by the time it arrives, you would have changed. And that sounds like a terrible idea, right?
Yes.
Yes, exactly.
This stuff gets much easier when everything's immutable.
Exactly. Like if you cannot change stuff like in Erlang, it becomes much, much easier, yes. So we made that and we made that fast. And then we said, okay, now we actually want to know when two processes are linked together. Like If one process needs to know that other process dies, how can we do that? And we implemented monitors, which is a feature of the Erlang VM as well, that allows one process to receive a message whenever a process it monitors dies, like it's terminated.
Right. Yeah.
And then we also implemented links, which also it's like an extension of that says if you link two processes together and either of them goes down, the other one goes down as well. Right?
Yeah. So now you can start to build up this supervisor tree thing that Erlang has. Yeah.
So now we said, okay, we have monitors, we have links. Let's build supervisors, right?
Yeah.
What's a supervisor? It's just a process that creates more processes and monitors them, right?
Yeah.
And then has a strategy for deciding how to keep the other processes, its child processes, alive, depending on how they die, right? You have many strategies. I think the only one we implemented right now is 1-for-1. So if you have a supervisor that has like 4 children and one of them sort of stops, then it will just restart 1 children, right? Okay. But we can implement other strategies such as 1-for-all, where it's like one of them goes down, everything goes down.
The musketeer pattern.
Exactly. Yes. Exactly. Literally. Okay. We might call it that. That's a good name. So we went there, and then once we had supervisors, right, we said, okay, so what else can we build here? Can we build Gen servers, right? The famed Erlang abstraction for building services inside of the Erlang VM. And it's a little harder.
Slow down a bit, because Gen servers, I'm not 100% sure I know what that is.
So a Gen server stands for generic server. Right. And it's a pattern inside of Erlang. Remember, we talked about the OTP, the Open Telecom Platform, right?
Yeah.
It has a bunch of things, that you can just reuse to say, oh, well, I'm going to need in my application, which is going to be like a microservice, like tiny universe, right?
Yeah.
I'm going to need one server for users and that handles like user requests.
Yeah.
And one server for like, I don't know, orders or things like that. These are not like HTTP servers. They're just like Erlang servers, right?
Yeah.
And the pattern of saying the server needs a queue of requests that come in, and it may receive requests asynchronously or synchronously, such as send, wait, respond, or just send and forget. That pattern with an internal state that is carried around in the server is just very, very common in the systems. So eventually the Erlang OTP library included this thing called Gen server, which allows you with very little overhead, right, to build one of the servers, and it manages state for you, and it manages all of the timeouts for the different calls. It has a bunch of logic implemented for you.
Right, yeah, with you.
So you just implement like, oh, what do I want to do when this specific request comes? And then you put your logic there, and that's it, right?
Right, yeah.
Just super powerful. Elixir also uses this a lot, right? But it works. I think it's powerful and easy to use on their end because it's not typed. And yeah, when we started typing it was like, holy crap, this is hard. Like there's a lot of tiny little things we need to do here. Some maybe even unsafe code inside of OCaml, right? To make sure that we can provide type-safe APIs to a user while still being flexible.
Take me into that, because it's from what you described, it doesn't immediately sound like typing is going to make that hard.
So there's a couple of design decisions, right, that we've been making. One of them is that there is a single message type for the entire system that works
per server or for the entire system.
For the entire system. So there's literally like a Riot message T. That's the type of all messages in Riot, right?
Okay, right.
And it's an extensible type. This is one of the trade-offs that some people really don't like, and some people go like, "Oh yeah, that sounds like we can run with this," right?
Okay.
In my head, it's like the right amount of type safety we need right now. In the future, we may change that. Right now, we're okay with this.
Okay.
Basically, if you need to create a new message, a message type, you can add a new constructor to that type. So then the entire system knows how to handle your messages now. And anybody that has access to that constructor, right, is able to create new messages of that kind and receive and like pattern match against messages of that kind.
Does that mean, I mean, in your example earlier, you were saying you've got one server for users and one server for orders. Does that,
yes.
Are you saying that the orders server will now have to know how to handle user messages?
No, it doesn't have to, right? It may be by the definition of like the receive function that we use to receive messages in a process. You may receive any message of the type message, right?
Yeah.
So you just don't know what message you get unless you pattern match the constructors.
Right.
So when you build your order server and you call receive,
Yeah.
and match on that, like you get the pattern match there. You could pattern match on users' messages, right? I don't think you'll get them. I don't think you'll be sending those messages to the order server, right?
Yeah.
This happens also in Erlang and Elixir, where you can send whatever message to whatever process, right?
Yeah.
And we have two ways to deal with this right now. The first one is that the constructors themselves have visibility rules in OCaml.
Okay.
So when you build your module for users, you can say, oh, these are the, create user or like delete user messages, right?
Yeah.
And they're private to this module. So
nobody else can
really
have a way
see
of guaranteeing a development time that user messages will be scoped to the user services.
So you may still receive any message, right? But you can say, I only care about these ones.
Okay.
And done. I think one thing that we're doing with Riot that goes a little bit against the ethos of OCaml is that with Riot, you can let your program crash, and that's okay.
Yeah, because you've got this other mechanism for that. Right?
Exactly.
Yeah. Okay.
But the second thing we're building, and we had it in an earlier version, but we removed it, and we're going to introduce it again, is the ability to write message selectors. So while the message type is large and has many constructors, right, you could specify a selecting function that says, whatever message we have in the mailbox, right, only give me the ones that fit this pattern or this function, right?
Yeah.
Like a filter, like a predicate.
Yeah.
And that would allow us, and this is a pattern that I thought it was a bad idea, and then I saw Glimmy's doing it, and I was like, okay, maybe it's a good idea. So, Louis, thank you for that. So we're going to bring it back. And it allows you to say, from this massive type of messages, right, you can constrain down to a very, very small, sort of space. Maybe even a single message, right, that you really, really care about. So these are sort of the ways in which we handle messages. And so on.
That makes sense. So you can narrow it down to just the domain. You just do it a slightly different way than having several message types.
Exactly.
Yeah. Okay.
Yes.
I've always wondered with this. I didn't know it was called Gen Server, but I've always wondered inside of Erlang, so in this case, inside of OCaml, how you are managing the under the hood, the mailbox thing, and the statefulness of the server and persistence thereof.
Yeah,
Tell me some more about that.
I wish I could just share some of the slides I had for the presentation.
No slides.
Yeah.
It's a podcast.
No slides. So can I draw in the air and then users pretend that they see what I'm drawing?
Some people are listening to this on Spotify, so you just have to paint pictures like radio.
Paint a picture. So imagine a square from coordinate 0 to 100. Realistically, right? A process in Riot, right, is a data structure. It's essentially a record or a struct that has a couple of interesting pieces of data. It knows its identity. It knows its identifier, right?
Yeah.
It knows the scheduler it currently runs on. And it also contains two different mailboxes, right?
Okay.
For all intents and purposes, they're the same. They're just used for when you're selecting messages. Sometimes we put some of the messages that didn't get selected into a separate mailbox so we can read them later.
Okay.
But the mailbox is a log-free queue. And when you are going to send a message to a process, you only have access to the identifier, the PID. The identifier is essentially an opaque integer. You don't really know that it's an integer, but it's unique for the longevity of the entire system. If you restart the server again, like the whole application, then another process will reuse an identifier, a PID. So they're not unique, across program executions. They're just unique during a program execution.
Right. Yeah. That makes sense.
And that PID is used as a lookup. So there's a small lookup into a big hash table, right?
Yeah.
Where we say, find me the process that belongs to this PID. And then we get the structure, which is the process. And we say, all right, let's access the mailbox of that process. And we'll put the pointer to the message. I say put the pointer. You don't do that, but OCaml does that, right? Into that queue, at the end of the queue.
Yeah.
There has been thoughts, I've been thinking about how to make this even more straightforward. So maybe the PID actually is a pointer to the mailbox directly. So you just put things in there.
Yeah, okay, I can see that.
Which could be faster. But right now, like that is not a concern right now. Like message passing is not really the bottleneck right now.
Okay.
So that's a little bit how it works. So you make any data structure, any piece of data that fits the message T type, and then you call the send function and you put the process ID and that value, the message.
Yep.
And then we put that at the bottom, at the end of the queue of the mailbox.
Okay. That seems straightforward. What about the state? Is that just a chunk of memory?
Well, we don't really handle that in Riot, right? Like Riot doesn't have access to the current state of a process. The way that we do that is that when you spin up a new process and we allocate the data structure, we allocate a continuation, right? We allocate essentially stopped function, like a whole stack trace that OCaml gives us the ability to stop and resume, right? And that's completely opaque to us. So if you want to manage state within your process, you need to build a recursion, for example. Yeah. So it's not uncommon to see that you have a spawn function, right? Calling to a function init. And that init function set up some initial state, and then it calls something like loop with that state, right?
Yeah.
And then that state in that loop just continuously, loops forever, essentially. And in its body, the loop function may do some things like, for example, it starts by saying, I need to read messages first. So I'm going to call receive, right? And then I'm just going to wait there until a message arrives. And then when we get a message like add user, then I will access the state, which is just a parameter to the loop function, right? And do something with that. Maybe update that state and then call loop again, right? To go back. Correct. And this is also the Erlang way and the Elixir way of handling, and the Glim way of handling state.
Then what do you do about persistence between runs? Is there any notion of, Erlang has like this built-in database system, doesn't it?
Yes.
That you can save your state to if you need to.
Correct. Erlang has 3 databases. You have ETS, Erlang term storage, which is in memory. You have DETS, which is disk-based Erlang term storage.
Okay.
And then you have Amnesia. And Amnesia builds on top of DETS, and it adds a lot of things on top, like the ability to do queries, do transactions, and stuff like that.
Okay.
We have started building something that we're just calling store, right? That is kind of like an OCaml term storage, right?
Right.
We do have a problem, which is that we don't have one type for all OCaml values, right? So we have to recur to a common pattern in OCaml, which is functors. Which is different than the typical functors people talk about from category theory in Haskell.
The typical functors that people talk about from category theory.
Yes.
Like they're in coffee shops, they're talking about category theory. No,
it is not free-range functors. These are like, lab-grown functors.
Yeah. What is an OCaml functor?
So an OCaml functor is a very interesting thing, right? It's a function from a module to a module. So it takes a module as an input and produces a new module as an output.
Okay.
And it's kind of crazy. It's a great way of doing sort of abstractions and patterns, because you can say, I need a store, right?
Yeah.
And I need the store to be a module that handles some kind of key type. So you can like put strings there, for example, and some kind of value type, like, for example, integers. So now we have this like table, the store from strings to ints, right?
Yeah.
And you need to always have, for example, a get function and a put function and some other functions in there, right?
Yeah, makes sense.
But you would like the store to be able to be customizable a little bit. For example, change the type of the value or change the type of the key, right?
Yep.
You could try to build this such that the module is generic, right? And then that means you get these 2 type parameters inside of as generics to a larger type, which is the type of the whole store, right?
Yep.
But that means you maybe cannot specialize certain things. Like, for example, how do you do the lookup, right, of a key, right? Because now you don't really know what the type is. It's going to be parameterized when someone creates a new store. And if you use a functor, you can say, I will give you a store if you give me a key type, right? Yeah. And a hashing function that I will use to find values of that key type, match them up together.
Yeah.
And then you create a store that is very optimized specifically for that specific key type you give me. And this is kind of weird to like explain, I think, without code, but it allows you to say, I'm going to give you a specialized version of a module, right? Giving some inputs, and the input happens to be another module with some functions or type definitions.
Yeah, okay. I can see why you want to take a more generic package module set of functions and make a more specific one. I'd not considered modeling that as a function from module to module, but sure.
Neither did I.
Yeah, okay.
Yeah, this is just something I learned, and I was very mad at them at the beginning because I didn't understand, and I think I understand better now. But I also try to avoid them because functors are powerful, but they're one of the type system and language features that are hardest to sort of, let's say, get up and running, right, and really grasp. They have a lot of gotchas. They have a lot of tiny things that are complex. Like if you have a type inside of the input module and you want to have the same type in the output module, right?
Yeah.
And you want the type system to know that these are the same, right? You also have to like have this annotation that tells the time system this type equality escapes this sort of module closure. And it's not the best developer experience, to be honest.
Okay, yeah.
Yeah. Anyways, so we're using one of those to be able to create these stores so that you can say, I want to save users. Okay. We give you a very easy way to create a user store, right?
Yeah.
And then that means you don't need Redis. You can just use that thing, right?
Okay. Yeah. Okay, that makes sense. While we're talking about persistence, then, I have often wondered, and this is my background in Kafka coming through, I think, that nice. You have mailboxes in this system, but if the system is expected to crash, if it crashes, it loses the whole mailbox.
Yes.
And I keep wondering, can we not build a version of Erlang or the Beam where the mailbox is more persistent? And if I crash, I can just replay the messages I lost since the last time I saved my state.
Yes, I think we could. The volume of messages, though, can be pretty big because the messages may be very tiny and sometimes they may be very large, right? Not necessarily the size of the message, but let's say the meaning of the message. For example, if I'm going to send in Erlang a string, the string may be like a really large piece of data, right?
Yeah.
Like potentially even gigabytes. But because Erlang is super optimized for this use case, then you're just really passing a pointer around, which is nice, right?
Yeah.
If you were to save that, then you will need, let's say, a persistent, like a transaction log, right, for the message. But you will also need to be able to persist all the data, right, that's associated with the message, including potentially 4 gigabytes of XML.
Yeah. Okay.
And that is like, we wouldn't do that in Kafka either, right? We would not send a 4 gigabyte message, right?
No.
You would put that somewhere else first, and then you will send the message, and then Kafka will persist the message. And when you get it, then you can go to the persistent store for the rest of the data and get it, right?
Yeah.
So I think that it would be hard to build like a one-size-fits-all solution here. It would be possible to do if you have like a very strict check on the message size. Like if you say, we will build a version of Riot that is meant to be persistent, but also running with like tiny messages, right?
Right, yeah.
So if you try to send a message this big, we go like, nope, you cannot send that.
So there is a future where you could have like an opt-in persistent message queue, provided you knew that it came with caveats.
Yeah, exactly. Like I've been thinking about it. What would it take to make Riot a little more, we could build soft real-time systems in the same way that we could with Erlang. But we have a lot of things that Erlang doesn't have, which I think makes us a little more flexible here. Like, for example, CLI tools in Erlang and Elixir have a problem, and they're slow to start, right? Because you need to boot the entire machine, and you have all of the setup for the schedulers and everything.
And this is a system that's expecting to run for 10 years at a time, right?
So it's completely fine, right? Like if it's going to run 10 years, 500 milliseconds of boot time, nobody cares, right? But I've gotten used to having fast startup in the OCaml ecosystem and its tools. So Riot ends up having a really fast startup time, right? Within 7 milliseconds or so in a modern MacBook, you have the tool running and you can have something running across all your cores already. So that enables some things, right, that Erlang just cannot do right now. And by design, maybe doesn't even care to do, which is fine. But it also means that we have less overhead in some things. Like if you were to do more, let's say, CPU bound work, I think OCaml is better suited for that than Erlang is, right? Primarily because it compiles to native code directly, right? And like ahead of time, so we can do a lot more optimizations there.
Okay, yeah.
The Erlang JIT is like fantastic, right? And the work Lucas Larsson has done with it is just incredible, right?
Yeah.
But it's still not designed for CPU bound workloads, right? It's more IO bound. And while Riot is IO bound as well, I think it will be interesting to see how far can we push it down to the real time, like actual real time workload space that maybe are more CPU bound, because the overhead of running processes is smaller and the startup time is also smaller and things like that.
Are we talking like hard real time there? Like you've got 50 milliseconds to answer this question, or
I think
we die?
To do that, we will need to do some work, OCaml itself.
Oh, okay.
Because right now we don't have a way of knowing, like the only point in which we can jump between processes, for example, is when we have an effect.
Right. Yeah. So you'd have to guarantee, without any change under the hood, you'd have to guarantee that any actor did actually call a wait in a reasonable amount of time.
Exactly. Yeah.
Yeah. So
we have an effect for that we call yield.
Yep.
And if you write an actor in Erlang and you do an infinite loop, like F calls F infinitely, Erlang doesn't care. It's like it will just run, and you can run anything else, and it will just schedule it properly. It will just a little bit of dead CPU time there. That's it.
Yeah.
For us, if you speed up an actor and you do while true, right?
Yeah.
Then you have bricked that scheduler, right?
Yeah.
So we have this effect that is just a function called yield that you can call anywhere, right? And ideally you can call in your hot loop, right? So that you tell the scheduler, hey, I'm doing a little bit of work at a time. Like, please consider descheduling me. Consider context switching to somebody else.
So you imbue your function with politeness.
Correct. Some people call it cooperative. I think polite scheduling is a better term for that.
Yeah.
So they're not so eager or greedy, right?
Yeah, but before I go back into my while loop for the billionth time, do you want to do anything?
Yes. Yeah, exactly. Would you maybe run for a millisecond before I take over again? Yeah. And I think that works okay. It would be much better if we could have preemptive scheduler, scheduling, so that even if you have a while true, then we eventually deschedule you, right? Like you run for more than 15 milliseconds or 15 microseconds or whatever.
Yeah.
Then go away.
But that definitely seems like it would need language changes.
I think the main language change we would need is not that big. It's almost like a compiler plugin, right? Like if we could inject a call to yield for you, right? At, let's say, the boundaries between function calls with gravy, right? That will be all that we need to do.
Okay,
Yeah, we haven't explored much what that would take because we haven't needed it yet. But I think as eventually one day in the future, Riot becomes more stable and gets closer to like a version 1, right? Then we would definitely want to have something like that. So people don't have to worry about like, oh no, I call this like, recursive function through these other 3 functions and I didn't realize, right? Like, you don't have to think about that. It just runs well.
Yeah, infinite while loops are easy to spot, but when it happens that A equals B equals C equals A, that can be harder.
Exactly,
yeah. Okay. Well, it sounds like you've got plenty of time to campaign for it to be in OCaml 6.
Probably, yeah. That's a very good idea, actually. I hadn't thought of that, so thank you.
Okay, cool. We've talked about multiple CPUs. I am wondering, because I think this is a thing that Erlang does, and I don't know if you do it in your project. I don't know if you're planning to. Can't you direct messages to an actor that might be running on a different server?
Ooh, good question. So Riot, one of the non-goals of Riot is distribution.
Oh, okay.
And in Erlang, distribution means you have different nodes running and you connect them together, and they get connected essentially by a third-party program to the VM, right? That's called EPMD, Erlang Port Daemon, Port Manager Daemon, which sort of keeps a track of where other Erlang nodes are running, right? And it tells the VM essentially, do you have any messages for this port, right? For this other node? Yeah, okay, I'll send a message through. That is not something that we couldn't do. We could do it, but to guarantee type safety across the nodes, that's a problem, right?
Yeah.
I think this is where I would say we don't want to do that, and we want to stick a queue in the middle. Like,
Okay.
Just use Kafka, right? That sort of thing.
That makes sense. So you've just raised another problem then, because type safety across nodes has almost the same problem as type safety between runs on the same node.
Yeah.
Like, if I bring my whole system down and bring it back up, what mechanisms have you got to deal with that? Because I need to deploy new code, but the assumption of the whole Erlang way of writing things is that the master process will run for a very, very long time.
I think this is more like a general problem, right? Like it would happen in Java, it would happen in like JavaScript.
Yeah.
Like if you have an external queue or a database, right? And you change the data model there, but you didn't change your program to deal with that, or vice versa, then you have the problem. At least in OCaml and type languages, we have the ability to say the user password changed from like, I don't know, an integer to a string. And that's a terrible way of saying it. The ID changed from an integer to a UID, right?
Yeah.
Like a string. Also probably bad, like to just store this UID as a string. But anyways, I think it's like, as an example, as a toy example, would be good, right? If we were to change that, you would have a way of knowing how your application reacts to that change, right? Before running it. So I think we have an advantage in that sense from untyped languages, where you would have to sort of try and have tests for these things, right? Whereas, OCaml, you just change the type, recompile, and it shows you this is everything that broke, right? So you already know what to do. But
I guess what I'm getting at, though, is do you have any plans for hot deployment?
Ooh, okay. Yes. No, that's also a non-goal.
Okay.
Yeah. So non-goal, definitely a non-goal. It would be really hard to do. I think it would be fun to do, and we might be able to do some of it. Like there were discussions at some point in the Erlang Ecosystem Foundation work groups, right, around type safety, of how could we guarantee some of this. And I remember I used to work at Erlang Solutions, and I had chats with Rover Birding about this as well. And how would you do some of this, right? You probably want to have, let's say, a hash of the information of the type, right? So you can compare whether this thing has changed or not. And you will want to be able to have a transition function from the old type to the new type, right?
Yeah.
To sort of guarantee that that's there. But it just sounds like more trouble than it's worth. In the same sense that I don't know a lot of people that do hot code reloads in Erlang or Elixir.
Oh, really? Is that an oversold and underused feature, are you saying?
No, those are not my words, but
sorry, yes.
No worries. I think that it is a great feature, and if you need it, then it's just fabulous that it's there, right? Klarna, I remember like actually copying a bytecode, like a .beam file, into a machine, right? And reloading that manually, just to be able to debug something, and it was just fabulous. But for most systems, what we have most of the state outside of the program, we try to build them stateless in some way, right?
Yeah.
So it's easy to say, well, if it's saved on the database, then you just like ship a new container, right? And it will be picked up. Because it does have the same problem. It doesn't have the type level problem, but you still have the problem that the type level problem surfaces early. When you have the types, it's like you change the type. Now you need this transitioning function between type A and type 1 and type 2, right? Like two versions of the same thing. Erlang, and this is also encoded in OTP, because clearly they have had this problem because they had the use case where you couldn't bring back the box and reprogram it. You had to sort of update the code there, right? While it was running. You have this idea of a code change. So you get a function, right, that has the information about the new code, right?
Yeah.
Or rather the old code and the old state, right? And this is a function the new code must implement. So you get a chance to do the handover between the two versions of the same module, right, on a single process. And this is like, we're talking you're in space and you need to sort of update a module, and here's the new copy of that. And the program kind of knows how to morph the data from one. It's just fantastic, right? It is like sci-fi almost, right?
Yeah, it's making me think of a scene in The Martian.
Yeah.
But yeah, I guess it's the same problem Kafka's wrestling with this. You get it anyway, you're doing schema migration, right?
Exactly.
You're going to have to deal with that. Yeah. Okay, so I've challenged you on 2 non-goals. Tell me where Riot is at right now and where you're taking it next.
So one of the things that we've been diligently, almost like obsessively doing with Riot is build vertically. So we started building with the idea that we want to have an entire vertical stack from the bottom, from like conditional compilation in OCaml that is done nicely, all the way up to we have a web server that does something like live view for Elixir. So we have essentially socket driven or socket based DOM patches sent to a website.
Okay, yeah.
And to do that, we build literally everything in the middle, right? We build new versions of strings for OCaml that have pattern matching like you would have in Elixir or Erlang. We build socket pools, HTTP server, WebSocket server, so new sort of protocol implementations for those things. And right now, we have this phase 1 of the project, which is meant to have a stack that can do that. Right. It might not be the most efficient. It might not be the most complete. Right. It would support HTTP1 and WebSockets. Right. It would cover some use cases. So if you want to build like your next sort of toy app side project with it, you can do it.
Yeah.
That will be like phase 1. On the next phases, hopefully we'll be able to cover more ground, support maybe HTTP2, give you an actual web server that has all of the bells and whistles that you expect out of something like Plug on Phoenix on Elixir, right?
Yep.
And at a lower level of the runtime, we're hoping to get some things like process stealing working correctly.
What's that?
So I love that feature. Process stealing was originally built for Riot a couple of months ago, but we have a couple of bugs. The idea is that once you spin a process in a scheduler, other schedulers that don't have anything to do can actually steal that, right? So you distribute the load across all of your cores automatically.
Okay. And that's and it's that way round. It's not like the server saying, I'm overloaded, you take this. It's the quiet CPU saying, well, I don't have enough to do. I'm taking that task from you. Exactly.
Like if you're busy doing something right now, you probably don't even know how many processes you have to run, right? Yep. And you don't want to like say, hey, does anybody want a process? Please take it from me. It's the other processes that are just idling that can say, well, you seem to have a lot on your plate, so I'll help with that.
Yeah.
And it has a couple of subtle bugs in it, so we had to roll that feature back. But the nice thing about it is that it helps you say, doesn't matter how many cores you have, doesn't matter how many processes you have, right? If you just keep spawning them to do work, idiomatically, of course, right? The process hierarchy. Eventually, you will distribute them across all of your cores, and the load will just be as fast as we can possibly make it.
Yeah.
And also low in the middle, of course, but.
Yeah, but that's nice that it would be self-load balancing in that way.
Yeah. And I think you can start to see with this couple of features like process that are suspendable, message passing, link supervisors, right? Process stealing across all the different schedulers.
Yeah.
How we're really bringing the Erlang VM to OCaml.
Yeah. And keeping the type system while you're there.
Exactly.
That'd be nice. Yeah.
Yeah. I tried to do the opposite before. I tried writing Caramel and bring the OCaml type system to Erlang, and that was hard. So I'm actually really happy that Louis just charged forward and Gleam V1 was released recently. I was so excited about that.
That's the way it should be, right? Us all shipping ideas from one language to another until we're all in the right place.
Until we all write, this mix of OCaml and Erlang.
Yeah. With some Haskell and Idris on the side, please?
Maybe sometimes if really necessary.
Okay. Cool. So where are you at for the future? Is this something where we should be encouraging people who are interested to try it out, to come and join the team and submit?
Absolutely. So
Patches?
we have 3 ways in which you, watching on YouTube, can contribute. The first one is use it, right? Build stuff with it, grab Riot. The OCaml ecosystem has a little bit of a rough start for newcomers. So be patient with that. We have Discord forums where we can help you with anything that you're experiencing there. But build things, because when you build things, bugs come out and we get to fix them and we get to make Riot better.
Yeah.
Now, if you already write a little OCaml or are enthusiastic about learning more OCaml and writing things, then you can also join some of the projects, right? We have about 5 different GitHub orgs for the different parts of the stack with some repos, each of them. And we have about 25 to 30 collaborators at the moment on all of them, which I am super excited about, by the way.
That's a decent number, yeah.
I'm most excited about the community we're building around Riot than Riot itself. It's like, yeah.
Yeah, I know you mean.
There's a lot of good first issues there that we are trying to put a lot of care into that to make it easier for you to pick up and say, okay, this is the problem. This is some implementation notes. This is maybe how you could test it, right? Yeah. So we can give you that package and you can just run away and implement it and come back to us in the process and contribute in that way. And then, of course, the last way of contributing to Riot right now is to sponsor us, either on the streams, right, where we're like essentially doing subscriptions. I believe that's subs, because we do a lot of live stream development for OCaml and Riot, right, and also GitHub sponsors, which we recently crossed like the 30-second sponsor, and
power of 2, love it.
Yeah, really good number, right? We're hoping for that 64 soon. And actually, like last week, we had one sponsor drop $1,000 a month, and I was like, "Holy crap! Someone is really betting on this, right?"
Yeah.
We even have one user of Riot that it replaced a small Erlang service with Riot, and we're waiting for approval from the company to be able to share more information about that, right? But I'm terrified because it's so early, right? It's like, no, please, what are you doing? But also excited because it shows that maybe there is a subset of Riot, right? That is stable enough for some workloads right now, which I think is interesting because I don't know what the subset is just yet, right?
Yeah, that's a really interesting time for a project.
I think so. I'm really excited about it. Yeah.
Well, I probably should leave you to get back on with it and get coding and feed your cat.
Sounds about right. I do need to feed Leia. Yes. I don't know. Oh, she's
there
asleep
somewhere.
over here.
She's there somewhere.
Yes.
So, Leandro, thank you very much for talking to us, and I wish you the best of luck on the road to Riot version 1.
Thank you so much, Chris, for having me. I will send you emails with people that you should definitely bring on board to talk about like Melange or OCaml and things like that, right? But again, thank you so much for having me, and I hope you have a great weekend.
You too. Cheers.
Cheers.
Do you know, I'm kind of jealous. That is a great time to be at the heart of a project. It's almost better than when it's successful. It's that period before when it's really starting to take off. Thank you, Leandro, and I wish you the very best of luck for what comes next. As we said, if you want to find out more, if you want to try Riot, if you want to support Riot, or if you want to take a look at the other languages we mentioned, like ReasonML and Rescript, all the links are in the show notes. Before you go and check there, if you've enjoyed this episode, please take a moment to like it, share it, and rate it. I always appreciate the feedback, of course, and it helps other people discover this episode too. And if you're not already subscribed, consider subscribing now, because we'll be back soon with another great mind from the software world and possibly another guest cat. I can't guarantee it, but we'll find out soon. And until we do, I've been your host, Chris Jenkins. This has been Developer Voices with Leandro Ostera. Thanks for listening.